Imagine you hire like an absolute master chef, someone who has been to all the finest culinary schools in the world.
Right, they have that perfect technique.
Exactly. They know how to properly dice an onion at the speed of light. They know exactly how to saute.
They understand those complex flavor profiles on an almost intuitive level.
Yeah, but then you ask them to cook this incredibly authentic, hyper-regional dish from, I don't know, a tiny village they've never even heard of.
Which is an issue
Yeah.
because they have all the core mechanical skills, right? The knife work is there, the heat management is there.
But they completely lack the specific, localized knowledge to make that one dish.
Exactly.
So as the person running the restaurant, you're faced with a choice. Do you send this master chef on a 3-month intensive culinary boot camp, just completely relocating them to that specific village to fundamentally change how they cook? Or do you just hand them the village's recipe book right before the dinner rush begins?
I mean, deciding between those two approaches is arguably the single most expensive, most consequential decision being made in the tech world right now.
It really is.
It's the core tension at the heart of modern artificial intelligence architecture.
Welcome to the deep dive. Today, we are taking you on a journey to demystify this exact architectural dilemma. We're looking at a scenario that trips up, honestly, even senior developers.
Oh, absolutely. Constantly.
And we found this fascinating breakdown of it in a highly concentrated source. Today's source is a transcript from a Code Cloud video, which is specifically preparing viewers for the AWS AI Practitioner exam.
Right.
We are focusing entirely on mechanics described in just a single question 39 out of 65.
And, the reason this specific exam question is so heavily debated is because getting this wrong in the real world costs companies millions of dollars and wasted compute time.
Millions, yeah.
The exam poses this massive architectural choice for a team building a generative AI application. The choice is basically, when do you model fine-tune and when do you use retrieval-augmented generation?
Which you'll usually hear referred to as RJ, right?
Yes, exactly. RG.
Well, the source outlines 4 specific engineering requests that a development team might face. But, rather than just listing them out like a boring table of contents, let's put you, the listener, in the shoes of a tech lead running an enterprise AI project.
I love that. Okay.
You have 4 different departments knocking on your door with requests for your AI model. So marketing wants the AI to write in a completely new style and tone of voice.
Classic marketing.
Right. Then engineering needs it to perform a brand new task, like generating code in a highly obscure niche programming language.
Sure.
Compliance needs it to produce outputs in a highly specific, totally consistent format every single time. And finally, finance wants the model to reference frequently updated stock information from external data sources.
I mean, it's kind of a nightmare scenario for a tech lead,
Oh,
but it's a brilliant framework for understanding how AI actually works under the hood. Because to fulfill those requests, you've got to decide when to completely rewire the AI's brain and when to just, hand it a textbook.
So let's start with rewiring the brain. Let's look at the request from marketing, engineering, and compliance.
Good.
So that's a new tone of voice, a niche coding task, and a consistent output format. The Code Cloud transcript groups these together under one umbrella, which is fine-tuning.
Right.
But wait, I have to challenge this right out of the gate. If marketing wants the AI to sound like, say, a 1920s noir detective, I can literally just type "act like a 1920s noir detective" into my prompt right now.
You can, yeah.
So why on earth would I spend thousands of dollars and weeks of compute time to structurally fine-tune a model just for a tone of voice?
It's a great question, and it really gets to the heart of what the source means when it says fine-tuning fundamentally changes the model's behavior.
Behavior.
Yes. Yes, so you can use prompting for a quick gimmick. You can constantly remind the AI, like, hey, remember, you are a noir detective. Right. But prompting is superficial. It takes up valuable space in your context window. And occasionally, the AI will just kind of slip up and break character because its fundamental instincts haven't changed at all.
Ah,
I see. So if you were building an enterprise application handling, 10,000 queries a minute, you really don't want to waste computational power constantly reminding the AI of its persona.
Okay, let's unpack this. So fine-tuning actually alters those instincts. The source uses a very specific technical phrase here. It says fine-tuning, quote, modifies the model weights that make up their neural network.
Yes.
How does modifying a weight translate to changing an instinct?
Well, think of a neural network as this massive web of mathematical probabilities. When the AI is generating text, it's essentially just guessing the most mathematically likely next word based on its training.
Like a super advanced autocomplete.
Exactly.
Yeah.
So a weight is really just the strength of the connection between different concepts.
Yeah.
So if you fine-tune the model on millions of 1920s detective novels, you are physically shifting the map inside the network. You're increasing the probability that the word dame follows the word classy and decreasing the probability of, like, modern slang.
Oh, wow. So the model no longer needs to be told to act like a detective.
Mathematically, it simply wants to speak that way. That is what the source means by establishing a learned behavior pattern.
That makes total sense. We aren't just giving it a script to read. We are changing its underlying grammatical physics.
That's a great way to put it. Grammatical physics.
Yeah.
And the same logic applies to those other two requests we mentioned.
Right, the coding and the formatting.
Yeah, if engineering needs the AI to write in an obscure coding language it's never seen before, prompting just won't work. You can't just paste a whole programming language manual into a prompt box.
The context window would just max out.
Exactly. You have to shift the neural weights so the model fundamentally understands the syntax of that new language.
Precisely. And for the compliance department's request, producing a highly specific, consistent format, it's the exact same mechanism, right?
Oh, totally. If you need a perfectly structured 5-column output with very specific comma separations every single time, fine-tuning modifies the weights so that breaking that structural format becomes mathematically improbable for the AI.
You are baking that behavior deeply into its architecture.
You are.
Baking it in. I'm glad you brought up that phrase, actually, because the Code Cloud transcript uses it, and it triggers a massive architectural red flag for me.
Oh, how so?
Well, the source explicitly warns that when you modify these weights, the data gets baked in at training time. It then warns that this information can go stale.
Right, yes.
So if we are sending our metaphorical chef to a multi-year boot camp to permanently rewire how they cook, what is the inherent risk if the culinary world changes tomorrow?
The risk is total obsolescence. And it's the exact vulnerability the AWS exam is trying to expose here. Yeah. When something is baked in at training time, it becomes this permanent frozen artifact of that specific moment. The training process, like shifting those millions or billions of mathematical weights, it requires massive clusters of GPUs running for days, weeks, or even months.
It's a massive capital investment.
Massive. And once that training run is finally finished, the model is essentially locked in a vault. It does not know what happens in the world the very next day.
Wow.
So if you fine-tune a model to understand a niche coding language, and the developers of that language release a huge update the very next week that changes the syntax, your model has no idea.
Because it's locked in the vault.
Exactly.
Yeah.
Its weights are set, its behavior is set based on the old version, the knowledge is baked in, and as the source warns, it has gone stale.
To fix it, you'd have to tear the whole house down to the studs. You'd have to undergo another entirely new, wildly expensive fine-tuning process just to update those neural weights with the new syntax rules.
Which brings us to the fourth department knocking on your door.
Finance. Right. Finance wants the model to reference frequently updated stock information. They need real-time external data. And clearly, based on what we just uncovered about training time, you cannot send your AI to a multi-million-dollar training boot camp every single afternoon just to learn today's closing bell prices.
You absolutely cannot. It's impossible.
Yeah.
If you tried to fine-tune a model on daily stock prices, by the time the training run finished next month, the data would be ancient history.
Yeah, totally useless.
And that pivots us directly to the alternative architectural approach, which the source identifies as the definitive correct answer for dealing with frequently updated information.
Which is RIU, Retrieval-Augmented Generation.
Yes.
Okay, let's break down the mechanics of RAG, because the source draws a really fascinating line in the sand regarding the timeline. We just established that fine-tuning happens at training time.
Right.
The AI learns, the weights shift, the training ends, and the model is deployed. But RAG operates on a completely different timeline. The source emphasizes that RAG operates at query time.
And understanding that difference, that is what separates a novice from an expert.
Query time, so that...
Query time is the exact millisecond a user hits enter on their keyboard.
Okay.
When a user asks the AI for the latest stock price, RAG doesn't look inward at the model's baked-in neural weights. Instead, RAG reaches out to an external data source, like a live financial database, pulls the freshest, most current numbers right at that very second, and feeds them to the model alongside the user's question.
Okay, here's where it gets really interesting. If fine-tuning is sending the chef off to an intensive, multi-year culinary program to fundamentally rewire their skills, ARG is literally just handing the chef an updated recipe card right as the dinner ticket prints.
Yes.
It is an open book test.
It is the ultimate open book test.
No,
And
no.
here's the most crucial mechanical advantage detailed in the transcript. Because you are operating at query time, there is absolutely zero retraining needed.
Wait, none at all. We are completely bypassing the neural network weight changes.
Completely bypassing them. You aren't touching the weights at all. The foundation model already has the behavior baked in, right?
Yeah, it already knows English.
Exactly. It already knows how to read English, how to comprehend numbers, and how to generate a coherent sentence. You don't need to retrain its linguistic instincts.
So RG just gives it the facts.
Right. RH simply grabs the fresh data, packages it up, and essentially says to the model, hey, use your existing reading and writing skills to answer this user's question, but base your answer exclusively on this fresh external document I am sliding across the desk right now.
That is wildly efficient. It completely eliminates the risk of information going stale.
Yes, it does.
If I'm building an app for you, the listener, and your data changes daily, weekly, or even second by second, RH is the structural mechanism that keeps the AI tethered to reality.
And think about the compute cost savings alone. You aren't spinning up huge GPU clusters to shift mathematical probabilities. You are just running a quick database search and handing the results to a model that already knows how to talk.
Wow. So, having explored the heavy architectural modifications of fine-tuning and the lightweight query time retrieval of RAG, the Code Cloud transcript actually synthesizes these two complex concepts into a beautifully simple rule of thumb.
It really is a golden rule for anyone building in this space.
So the source boils the entire debate down to this phrase. RAG is for knowledge. Fine-tuning is for behavior.
RAG is for knowledge. Fine-tuning is for behavior.
I love how clean that is. Let's map our dev team's requests against that rule just to solidify the mechanics. Marketing wanted a new tone of voice. That is fundamentally changing how the model acts. That's behavior, so we fine-tune.
Right. And compliance wanted a highly specific, consistent output format. Again, that is changing the structural instinct of the model. Behavior. Fine-tune.
Engineering needed the model to perform a new task, writing in a niche coding language it had never seen before. That requires shifting the neural weights to understand new syntax. Behavior. Fine-tune.
Plus finance.
Right, finance.
Finance needed the model to reference frequently updated external stock data. That isn't about changing how the model acts. It's about changing what it currently knows. Knowledge.
Yeah.
And because that knowledge changes rapidly,
Yeah.
you pull it at query time. No retraining needed. RAG.
And that is exactly why the source identifies RAG as the undisputed correct answer for dealing with external, frequently updated data on the AWS exam.
Exactly.
So what does this all mean for you? I want to push back on this a little bit. RAG is for knowledge, fine-tuning is for behavior, is a fantastic, clean distinction for a multiple choice test.
Sure.
It makes it easy to circle B and move on. But out in the wild, enterprise applications aren't multiple choice. The source makes it sound like an either decision.
Right, right.
But if you are building a truly cutting-edge application, isn't it true that you rarely get to just pick one? I mean, is it fair to say that building a real application requires pulling both of these technical levers at the same time?
Oh, absolutely. You're hitting on the exact reason why certifications only tell half the story. Yes, the AWS exam forces you to isolate the variables. It isolates frequently updated information to prove that you understand the mechanics of query time retrieval.
Right.
It makes you demonstrate that you know a hammer from a screwdriver.
Right.
But you are entirely correct. The reality of building enterprise-grade AI is recognizing that you almost always need to use both tools to build the house.
Because if you just rely on RAG, your model might have all the right facts, but it won't have the instinctual capabilities or the tone your brand requires.
Exactly. And if you only rely on fine-tuning, you might have a beautifully eloquent model that confidently hallucinates incredibly outdated information.
Confidently wrong.
Confidently wrong, which is the worst kind of wrong. Modern AI architecture is about matching the technical approach to the fundamental nature of the problem, layer by layer.
So you layer them.
You layer them. You use fine-tuning to shape the AI's foundational identity. You spend the compute time to bake in its tone, its format compliance, its syntactic understanding. You lock in the behavior.
Right.
But then you build a RAG architecture on top of that foundation to constantly feed it the real-time facts it needs to operate in today's reality.
It's back to the chef analogy.
Yes. You give the master chef their intensive culinary training so they know how to cook perfectly, but you still hand them the daily specials board every morning so they know what to cook today.
I love that. It's amazing how a single scenario, just question 39 out of 65, holds so much architectural philosophy inside it once you stop looking at it as a test question and start looking at it as an engineering blueprint.
It really does.
We've covered some serious ground today. We unpacked how fine-tuning fundamentally alters neural network weights, shifting mathematical probabilities to basically bake in behaviors like a noir tone of voice or a niche coding language.
Yep.
We looked at the massive compute costs of training time and that inherent risk of baked-in data going stale.
And we contrasted those heavy modifications with the sort of agile mechanics of RAG. We saw how RAG operates at query time, just bypassing the neural weights entirely to pull fresh, external data at the exact moment a user asks a question.
Which ensures the model's knowledge never becomes obsolete.
Exactly.
That golden rule from the Code Cloud transcript, RAG for knowledge, fine-tuning for behavior, it gives you an incredibly sharp lens for looking at any AI application.
It's so useful.
The next time you use a tool and it gives you a perfectly formatted summary of today's news, you now know exactly what is happening under the hood. The formatting was fine-tuned into its weights months ago. The news was arg-retrieved milliseconds ago.
It completely changes how you interact with the technology.
Yeah.
But before we wrap up, I want to leave you with a final thought to ponder. A kind of puzzle that builds directly on the clear dividing line we've established today.
Oh, I like puzzles. Let's hear it.
Well, we've established that fine-tuning is for behavior and RAG is for knowledge, right?
Okay.
But imagine you are tasked with building a generative AI that needs to write complex code in an obscure, highly niche programming language. As the source tells us, teaching it that syntax requires modifying its weights, fine-tuning its behavior.
Okay, behavior. Check.
But imagine the dependencies. The software libraries and the best practices for that niche language are updated daily by an external open source community.
Oh, I see where this is going.
Right. Which, of course, requires RA to access that fresh, real-time knowledge.
Oh, wow. Wait, really? So the behavior itself is constantly changing based on the knowledge.
Exactly. So how would you design an application architecture that needs to simultaneously change its fundamental structural behavior and its real-time knowledge without going bankrupt on daily retraining costs?
Man. Now that is an engineering puzzle worth chewing on.
It definitely is.
Well, thank you for joining us on this deep dive. Keep questioning the mechanics behind the technology you use every day. Keep looking under the hood, and we'll see you next time.